So in the previous video, I have shown you and explained what are the three components of a time series dataset. So they are seasonal component, trend component, and the remainder component. So when you work with time series dataset, it is important to know how to decompose these components from a time series dataset. So this is also known as STL decomposition. So in here, STL stands for seasonal and trend decomposition. So in this video, I'm going to show you two methods that we can use to decompose a time series dataset. So for this example, I'm going to use a temperature dataset with regards to the ecological regions in United States of America. So first of all, we have to examine the dataset. So I have already imported set into R, and let's check how the data is arranged. So in here you can see the month and the year is given in the first column, and in the respective columns the area, and it indicates the temperature of this each area with respect to the time and the year. So in this example, I am going to consider only Arizona, New Mexico mountains temperature. Therefore, I am going to filter out only this part of the entire dataset. Therefore, I am going to create a time series dataset. Then I am going to use this variable to filter this particular data. So we know that it is indicated in the second column, so we will consider the second column for this. So next we have to examine the period of data. So in here you can see it starts from the 1950 January. So for the end with the 2099 December. However, for this, because they have made a prediction up to 2099. However, for this example, I am only considering temperature up to 2020. Therefore, I will filter out the data between the starting of this period and ending with the 2020 December. So first of all, I have to create a time series object. So I am going to name it as TS temp region, and then we can call the TS function as usual and provide the TS data, and then we can concatenate and include the starting date, which is 1950 January, and the time series dataset ends with 2020 December. Since it is an annual dataset, we will use the frequency as 12. So in this way we can create a time series dataset. So first of all, we'll plot this and see how the data is arranged. So let's run this. So in here I have included the wrong argument. We have to use this variable instead of T regions. So let's run it again. So now when you zoom it, you can see how the actual data is arranged. So by looking at this, you can clearly see a particular seasonal change and repeating cycle over the years. So in the next step, we will import, or we will call decompose function in order to decompose the STL components. So in here you have to make some assumptions or judgments. So you have to call this decompose function. And when you provide the type of this decomposition, you have to specify whether it is an additive or multiplicative. So for that you have to get an specific idea regarding the data set. So in normal circumstances or normally in a multiplicative time series, the components multiply together and make the time series. So for an example, if you have an increase in trend, the amplitude of that seasonal activity increases and everything becomes more exaggerated over time. However, on the other hand, in an additive time series, the components add together to make the time series. Even though if you have an increase in trend, in additive time series, you still see roughly the same size peaks and troughs throughout the time series. So we can often see in index time series where the absolute value is growing, but the changes stay relative. So by looking at this trend, you can clearly see it is not an increase in trend, but an additive trend. Therefore, so in here, we will include the type as additive instead of multiplicative. So then we can plot this. Let's run this. So when you zoom in, you can see this is the observed data set, and here you can see a particular trend and also seasonal variation as well. So this is the how decomposition works with decompose function. So when you are working, you have to make sure that you enter the correct type of, whether it is an additive or multiplicative. So if there are situations that you are not familiar with the particular type, you can use a different decomposition method. So it is called the STL decomposition. So in here you have to call the STL function and give the TS temp region or the particular time series data set. And mention it as period. So let's run this. So now you can see the both of these decomposition functions gave the same results. So if you have entered the wrong type of decomposition, like instead of additive, if you give the multi, it will give two different graphs. So there is an chance of making an error selecting the type of graph when you are working with decompose function. So in these situations, you can use the STL function instead of decompose function. You can also extract each of the components very easily with this. So for an example, if you want to get the seasonal component, you can just define a variable and call the particular component. So if you plot this, you will get the seasonal component of that particular decomposition. So likewise, you can use these both methods to decompose your time series dataset into 3 components. See you in the next video.